Hello. Yeah, dear all students, please all of you join to microprocessor class because of your regular class teacher, that is madam is so busy, so I have to conduct class. Actually, my last hour is mine. Last hour as well as this hour I have to conduct class. So just again 2 more minutes. I will wait for to join some other students because very the students are there. So we will start 1 or 2 minutes.
Okay, sir.
Okay, thank you. Please, all of you, make your mute your device. Rule number A35 double A. Please make your mute. Yes, fine. Uh, Now I will say So yes, still more students are waiting. Please join all of you soon. Yes, very less friends, only 86 friends out of 140. Join, please be fast. Okay, dear all students, uh, still the today's class, I have to completed first unit of your microprocessor subject. So just I will recall you before going to second unit. So actually today I have a plan to start your second unit. So before going to second unit, just I will recall your previous first unit. So in that, all of you get cleared or any doubts with you?
Hello, sir.
Yeah, please.
Sir, architecture once again repeat, sir.
Once again, can I explain architecture?
Yes, sir.
Yes, fine. Is there any more? Is there any more questions from any other students? Just one second. Uh, that is this. So here on Friday, I was shared you that PPT. So just I will go through that PPT once again. So see, one more thing, dear all students, I have to create one of the new group for microprocessor subject. So please, all of you join into that microprocessor subject. Uh, and each and every discussion and every material, I have to send it into that microprocessor group. So it's taking too much time for loading. Friday, I have to conduct a last class that is on Friday. So in that Friday, I provide you notes also, right? Uh, yes. It's over. So just a minute, because I have to place on my PC. That's what I am getting. In the morning session. See, please, whatever I saved you last my notes, can you share with me? Please, anyone share to my personal WhatsApp that notes. Yeah, please share with me.
Hello, sir.
Yeah,
I can share, sir, microprocessor group.
in the micro A and B. Okay, that's yes, fine. Fine, now I am getting that. Yeah. Okay, fine. Dear students. Okay, and I will admit it to all of you. Now I got admitted. Yes, fine. This your third session, that is actually 2:30 to 3:30. We have to discuss about previous topics. Actually, in my class, that is from 3:30 to 4:30. I have to exist. Okay. So previous that, okay, only 90% are get admitted. What about remaining? Yes, fine. So one question I got from student, that is architecture of microprocessor. So dear all students, that's the last topic of first unit, that is architecture of 8085 microprocessor. It's architecture, okay? So before this is the last topic of your first unit. So previous to the topics, these many topics, any doubts, please can you? I will go and see if you have any doubts with those. If there is no any doubts, then I
Hello,
will
sir.
go to only my architecture. So before that, just I will request you, dear all students, as per the syllabus, the first unit is Introduction to Microprocessor. In that, you are going to study definitions of microprocessor. Out of these three, anyone you have to give, no problem. And you have to go for components of microprocessor. In the components of microprocessor, there are mainly three parts: arithmetic and logic, register and control. Just you have to go through it, and all the explanations is available here. And next, that is system bus. In that system bus also you have to study for control bus, address bus and data bus. All these buses are explanation are given to here. Next, you have to go for that microcontroller bus organization. How that bus is going to be connected with all the full peripheral devices of microprocessor. That one we have to study. All these are that diagram and all the explanations are given to you. Please you go through it. Later on, you go for features and pin diagram of 8085. So first you have to study the features of 8085. So here 12 points are given to you. Each points you have to explain in detail. Someone admitted. Yes, so I was admitted to everyone. Yes, fine. So these 12 points you have to go through it for the features. After that, there is a 40 pin 8085 microprocessor. All the pins you have to study it very well. These all 20 plus 20, right side 20 and left side 20. So totally 30 pins you have to study in detail, and each pin, what is the functionality, and particular pin is used for what, and what is that instruction. Okay, all those things you have to study. Once that pin diagram is over, next you will come to the so all the pin diagrams also I have to give an explanation to you with a particular mentioning pin number to the particular instruction. So later on, now we will go for architecture, that is 8085 architecture. So now I got a question on this. Someone students are asking, that is to re-explanation of 8085 microprocessor architecture. So in this first unit, you are going to study that is 8085 microprocessor architecture, and in the second unit, you are going to be that is 8086 microprocessor architecture. So now I will explain you about, just I will already done, but I will repetition about you for architecture of 8085 microprocessor. So here all of you just you observe that whatever the different blocks whatever the different blocks we are going to be used in the 8085, those we have to made it in a systematically manner, and we have to prepare a one frame structure, one framework, that is nothing but your architecture. So in this architecture, we have to use mainly 6 to 7 blocks. First block is interrupt control. First block is interrupt control. Second block is serial input and output control. There are totally two control parts. One is interrupt control and one more is serial input and output control. And one more block is 8-bit internal data buses we have to use it. And after that, one more block we have to use it ALU, algebraic and logical unit block. And one more, that is instruction register and decoder we have to use. And the next one we have to use it for the registers, that is stack pointer and program counter. In that we have to use different kind of registers for the storage of data and information. So these are the number of registers. And we have one more block, that is timing and control circuit. So that is for the clock generator. Now we have to use it. And next one, that is address and data. So that is data and address buffer, and only the address buffer. So these, how many? There is a control, interrupt control first, serial input output control second one, data bus, that's the 8-bit data bus. Third one, in the ALU. Fourth one, that instruction register and decoder. Fifth one, that stock pointer, that is a register, nothing but. Sixth one, and timing and control. Seventh one, address and data address bus. Eighth one. So like that, totally 8 blocks we are going to study in detail in the 8085 microprocessor architecture. So in each block, all the 8 blocks, now one by one we will go through it. So here in the interrupt control, as already we studied in the pin diagram of 8085, these are the pins are going to be connected, and already this functionality you know that. And in that serial input output also, you have to use the SID and SOD in the pin numbers, you remember that. And in the ALU, that we have to use the accumulator. Accumulator is nothing but main memory, and one temporary registers memory we have to use it for to manipulate the data, read and write purpose. And totally 5 flags we have to use it. That flags we are going to study in the second unit. Today I have to start your second unit. That time we will explain you whenever that topic comes. So, and instruction registers, these are the used for instruction register and coder decoder. We are going to be used for storage of the memory. That is nothing but our registers. So in that we are going to be stored. So these BC, DE, HL, these are the pair registers we have to use it. And SP is nothing but your stack pointer. PC is nothing but your program pointer. So next, address buffers and data address buffers for transmitting the data based on the speed. Based on the speed, we have to use it. Address, that is the AD0 lines, and data and address line, that is the D0 to D7. Okay, so like that we have to use it. Address bus AD0 to AD7, and only the address bus A8 to A15. Next, data bus, that is AD0 to AD7. So this is a microprocessor. So this explanation now, we will go to the explanation how we are going to be explain this entire blocks. So here first I will go through it. See, either you have to use this diagram or you have to use this diagram. Both are same, no problem. Both you have to use it, you will get a full marks. So in detail, he is clearly mentioned. Okay, in all the blocks he is clearly mentioned. That's what I have to use it. Both are the same. Anyone you can use it. So now I'll go to the one by one in that diagram. That is the accumulator. I will go to first. So the accumulator is nothing but what? It is a 8-bit data register to perform arithmetic and logical units. That is input and output for load and storage operations. We are done by the work of accumulator. So in that accumulator, that we have to using ALU. So ALU means what? That is a arithmetic and logical unit. So in that, as the name suggests, it performs arithmetic and logical operations, and like addition, subtraction, and all the logical gates like OR and operations. So those things we are going to be the main functionality of this ALU. So next one, that is general purpose registers. So this block I am going to general purpose registers are these many. that is BC pair, DE pair, and HL pair. So here, in the general purpose register, you have to use it B, C, D, E, H, and L. So B, C, D, E, you have to use it, and A is for already reserved, that is accumulator. That's what you didn't use A as a general purpose. So you start with B, B, C, one pair, D, E, one more pair, and H and L, two more registers are there. That is, H means high storage data input, and L means low storage data inputs. Okay. So after that, you go to the program counter. What the program counter will do? It will to host the address of next instruction to going to be execute. So that is the microprocessor implements of the program whenever an instruction is being executed. So that the program counter points to the memory address. Okay. So and that is going to be hold the address of another memory, that program counter. So it's like works as a pointer in your C programming. Okay. So next one is a stack pointer. It is related to the memory. So in that it is a 16-bit register like words, and which is to always incremented or decremented by a 2 because of 16-bit. Because of 16-bit, each time it is going to be decremented or incremented by 2 bits. Okay. If it is a 8-bit, then it is a decremented or incremented by a 1 bit. So next, temporary register. So in what the temporary is, these are the used for temporary storage purpose. The name itself indicates register is nothing but a storage, and temporary is nothing but temporary storage. So in this, it is an 8-bit register which holds the temporary data of the arithmetic and logical operations. So next one, flags. These are the 5 flags are there. Just to remember these 5 flags and where in which bit it is going to be worked. So carry flag, that is a AC, auxiliary carry flag, which is going to be works in the bit of D4, and that is S means sign flag, that is going to be D7. Z means zero flag, that is in the bit of in a data line series of D6. Auxiliary carry flag at D4, and parity flag at D2, and carry flag at D0. Like that, these flags are going to be set. Either it make it as this flag is going to be set with 0 or 1. Whenever going to be 0, it will not work. Whenever you have to going to be set, it will going to be works as per the flags, either on or off mode conditions. Okay, those flags we will study in detail in the unit number 2. Not that much bother now as in the architecture. Immediately I will start your second unit. In that I have to explain you. So later on we'll come to the instruction registers and decoder. So what these instruction registers and decoder will do, in that 8-bit register, whenever an instruction is fetched from the memory, that it is stored in the instruction register. So in that instruction register, all the manipulation is happened, that is BC, DE, and HL register, and make it into decoder and decodes the information present in the instruction register. Okay. So after that, that's the timing and control unit. So this one, that's the timing and control unit. In that, all these clocks are used. Hold acknowledgement is used. So for that, we have to provide mainly control signals. We have to use it. Nothing but ready state, read state, write state, and that is latch enable. Okay, and status signals we have to use it S0, S19, input output or memory, and also we have to use it dynamic memory access signals, that is hold there and hold acknowledgements. So and we have to use it reset signals for resetting. Again, to start with the beginning, that is reset in and reset out. Both in and out we have to going to reset it. Okay. So and at the last blend, that's interrupt control. So in the interrupt controls, you have to use it at the first block. So this is the interrupt control block as our diagram. Interrupt controls. So what is the interrupts? There is some abnormalities occurs during the execution of a program, microprocessor program. That time that interrupt control is going to be helps the microprocessor. In that, the name suggests to control interrupts during the process. When a microprocessor executes a main program, whenever an interrupt occurs. Okay, interrupts means some abnormalities occurs. So in this, the microprocessor shifts the control from the main program to the process the incoming request. Okay. So what are mainly things in the control interrupt? Nothing but there are 5 main interrupts, which is INTR, nothing but a normal interrupt, and reset 7.5. These are the series 7.5, 6.5, and 5.5. Three main series of your interrupt reset requests, and one more we have to use it for the trap. So by using all these 5 interrupts, we are going to be handle some abnormal conditions, some abnormal execution in the microprocessor. Okay. So after that, we'll go for serial input and output, that is SID and SOD. There are two. One is serial input data and one more is serial output data. That is going to be controlled with the serial data communication by using these two, SID and SOD. So these two main functions that is present in your first block of here. This one, SID and SOD, in the serial input and output control. So next one, we'll go to address bus and data bus. As you know, address bus, that is A to A15, and address data bus, that is AD0 to AD7. Those you have to use it in the pin diagram of microprocessor also. So they just these address lines are going to be transfer the data from source to destinations and receive the data from destination to source up to the executions. So entire this architecture of 8085 microprocessor. So again, I repeat it. Uh, okay, is it okay?
Yes, sir. Understand.
Yes, fine. Thank you. Is there any more questions again? Okay, students. In my notes, I will give some suggestions how you are going to study. So whatever I have to mention, it is appropriate point to you as per your syllabus. So all these things you have to make a note, study well, and whatever the questions is occurs, it is more than enough for this so much information is more than enough for you. So and also at the last page, I have to return some summary of the unit. So as per syllabus, I have to cover definitions of microprocessor. I have to cover components in that ALU, register, and control unit, and I have to cover system bus, that is data, address, and control buses, and I have to control microprocessor system bus organization with the system. And the second main point, that is features, I have to cover, and pin diagrams also I have to cover. In that minimum 12 to 10 to 12 features I given to you. All you have to go through it. After that, there's the pin diagrams. All the pin diagrams in that, whatever the different instructions are coming with the 40 pins, all I have to explain them just to go through it. At the last, that is architecture of 8085, or you say it's a block diagram also sometimes. So in that you have to study accumulator, arithmetic and logic, ALU, general purpose register, program counter, stack pointer, temporary register, flag register, instruction set register and decoder, timing and control in it, interrupt control, serial input and output control. So address buffer and address data buffers, address bus and data buses. All these clear, I have to explain it and I given you clear notes. I think more than 100% it is enough for you. So still, yes, is there any notes? Please discuss with me. Otherwise, I will move to second unit of today. And now I announce that in next class, in next maybe tomorrow or day after tomorrow is, I think it is the Dasara holiday is there. Maybe tomorrow I am going to conduct one test, and today I will give you some multiple choice questions based on your first unit. Based on your first unit, I'll give you some multiple choice question. Please all of you read it, and shortly I have to conduct one test. Okay, some students are waiting. Yes, I admitted. Fine. Okay. So at a short time, I'm going to conduct one test for your first unit. All of you be ready.
नाही इथे चालू आहे.
Make your mute, please. Yes, fine. Okay. So if you have any questions, then you unmute and ask the questions. If no questions, please mute it always. As fine. If any questions, please you write in chat box also, no problem. Chat box also you have to write. I will accept through the WhatsApp also you have to do chat. Is there any? I'll check it WhatsApp. Okay. Microprocessor unit one. Yes, fine. Uh, no questions, no chat. I'll go to. Okay. So, dear students, this much is more than enough for your first unit. Whatever the question he may ask, you make perfect yourself. Whatever questions will be come from the university or in the internal or in the any kind of other external examiner as well in the lab. And one more thing, dear all students, I will announce you that for the microprocessor you have POE, practical overall examinations. So in this microprocessor, many instructions are comes. So some of the instructions we will study in the unit number 2 along with 8086 microprocessor architecture and all the flags. Once we complete the second unit, because in the second unit majority of the instructions are there. So once we studied all the instructions, whatever comes under the unit number 2, after that immediately we will start the lab sessions. So before starting lab sessions you must and should have the knowledge of whatever syllabus they have to study in the unit number 2. So that's what before starting lab sessions we have to cover uh, microprocessor unit number 2 in it, because that knowledge is most essential for to do the labs. And also all the dear students, in your computer or in your machine, please you go and install TASM software. There is a one software that is TASM software. Uh, Almost today evening, I'll send you that TASM software. Please all of you go and install in your machines for lab purpose. Okay. Uh, okay, fine. I think it's enough for you. So please, any questions, let me know regarding first unit. Otherwise, soon I'll start your second unit. Just now it's 3:20. Just for 5 minutes, I will give you recall these two notes. All of you go through these notes as well as PPT, whatever I shared with you for first unit. Okay. No questions means I think all of you are understood very well about first unit. Okay. Thank you. Thank you for your good response. Now I will move to second unit. So unit number 2. Okay, dear all students, can we move for unit number 2? Is there any more questions? Please reply.
No, sir, no questions.
Okay, thank you. We will move to the question number, sorry, the unit number 2. So, dear all students, in the unit number 2, so again, before that, we will go through a syllabus. We will go through syllabus, that is fine. So here, just a second. Yes, it's fine. Where is that? Use. Okay, I'll open just the syllabus of your second unit. Uh, in that, just control F. Okay, microcontroller. Next. Okay, fine. Dear all students, up to today, all of you go through the syllabus. This is the unit number 1. That is introduction to microprocessor. In that we have to cover introduction to microprocessor, features and pin diagrams of 8085 we covered, and architecture of microprocessor we covered. Okay, that is 4 hours of your first unit. Now I will move to unit number 2. Now I will move to unit number 2. Once we complete studied, so in the unit number 2, whatever the syllabus are there, that is 8086 microprocessor. In the unit number 1, whatever you studied up to now, that is 8085. That is 8085. Now onwards, from the unit number 2 onwards, you are going to study 8086 microprocessor syllabus. Okay. So here also you are going to study, that is architecture of 8086. At the first point only, you have to study architecture of 8085. Already you studied 8085 architecture, but it is bit different. It's like an extended version of your 8085. And in the second unit, you are going to study internal operations of 8086 architecture, and also you are going to study machine languages, instructions. So in this is very important part, that is machine languages instructions. Here minimum 50 to 60 instructions you are going to be study. All these instructions are very essential for to do the lab programs. That's what repeatedly I am saying you. Second unit is very important for your lab point of view, practical point of view. So in that instructions, along with the instructions you are studying again, addressing modes. There are main 5 addressing modes are there. And along with the addressing modes, all the flags you are studying in this topic. And later on you are going to be studies instruction execution time. Whatever you are studying machine language instructions, based on that you are going to be studying instruction execution timing as per each and every instructions. So this is a 6 hour chapter. Minimum I need 3 to 4 classes of each 2 hours. So up to this week and next week, I am going to complete your this chapter also. Within this month of October, I have to complete this your unit. That is second unit 8086 microprocessor. Keep all of you keep remembering, in the month of October, I have to going to cover first 2 units. First unit is already covered. Second unit I am going to cover in the month of October, and in the month of November, I am going to cover 3 units, unit number 3, unit number 4, 5. And in the month of December, I am going to cover these 3 units, that is 6 and 7, 8. So October month 2 units, November month 3 units, and December month 3 units. At the end of December, you have a university examination. Before that, I have to cover in the month of October, I have to cover only 2 units, means it's the beginning of the semester. I didn't give you too much load. That's what I will move slow at the beginning. So for that, I'm covering only 2 units. So now I'll start with your second unit, 8086 microprocessor. In that, I am started with your architecture of 8086 microprocessor again. So all of you get the syllabus. Now you come to the point, that is unit number 2, 8086 microprocessor. So next we will see the syllabus in my slide. Go to second slide. What are the syllabus here? In that you are going to study the architecture of 8085. So in the 8086 there are mainly 2 parts of architecture. So one is bus interface unit, and another one is execution unit. So in the bus interface unit, you have to study about how to writing a code, microprocessor code instructions you have to study it in the bus interface in it, and in the execution units you are going to be study how the instructions are going to be executed by using the TASM or MASM. Two softwares are there. By using those two tools, softwares, we are going to be execute all the instructions, and later on how the internal operations is going on in the microprocessor 8086, how the internal operations is going on. That one also we are going to study in this second unit. And the third main topic is that is machine language instructions. So this is very very important machine level language instructions. So in this all addressing modes we are going to be study. So with the instructions and all these addressing modes, once we perfect in this topic, easily we are going to be do the program part in the microprocessor. That is the practical sessions. So after that, once we know all the instructions, all the addressing modes and architecture of 8086 microprocessor along with bus interface in it and execution in it, we are going to be easily find the execution timing output, how the instructions are going to be executed within a how much specified time. Based on that we have to going to study. So this part, as for that, this part is very very important for your practical point of view. So for the second unit, all of you refer to this book, textbook, that is Microcomputer Systems, the 8086 and 8088 family, and the name of the author, that is Yu Chuang Liu and Glenn A. Gibson. So Chang and Gibson, these authors' book, that is Microcomputer Systems 8086. That one you have to collect from the library. In the library, many books are available. And before going to study this book, all of you again go and use my prepared notes. So as per higher authority suggestions, in the first unit, I'll give you printed notes. But in the second module onwards, as per the higher authority suggestions, I will give you my handwritten notes. Whatever I have to write the notes by my hand, those notes I will transfer to you this units onwards because of your higher authority suggestions. Okay. So in this, for this model, I have to prepare some notes PPT. So this is the PPT. Actual topic starts with your 8086 features and 8086 architecture. So and along with that also I have to prepare uh, yeah please. Yes, fine here. So in this, again, that is the models where file. So it topic. Okay, anyhow, I will send you that notes also, no problem. So along with this, we are now start with our actual syllabus of second unit. So from the second unit, see, first we will, before going to study the architecture, just we will check about the features of 8086 as our features of 8085. So the 8086 having a buses was already what you studied. See, this almost 8086 is same as your 8085, just it is extended version like your C and C++. C is the basic language. C++ is extended of C, right? So like that, 8086 is also a extended of your 8085. So in the 8085, you are using buses. Again, you are going to use all those three types of buses. What are those? Control bus, address bus, and data bus. These three buses are supported by 8086 also. And in the 8086, it is supporting pipelining. But one thing you remember that 8085 is not supporting pipelining. But in the 8086, the main features of 8086 it is supporting pipelining. Okay. And the next point, that is 8086 has two operating modes. What are two operating modes? That is minimum mode and maximum mode. So in the later on syllabus we will cover it. So it will obey minimum mode and maximum mode of 8086, which is not present in our 8085. And also in 8086 it is having a 256 interrupts. In 8085 you
Sir,
studied
some
only
students
5
are in
interrupts.
waiting room. Please admit them.
Yeah, please.
Some students are at waiting room, sir.
Yeah, waiting. Okay, sorry. No, only two students are waiting. Gokhale and Kulwar. Yes, I get admitted. I get admitted. Okay. So,
Sir,
here, yeah,
what is that supports pipelining in microprocessor?
yeah, please. I didn't get you.
Hello.
Yeah, yeah. Tell me.
So what is that microprocessor supports pipelining?
Okay. So you see, these are the features we will study it in detail in the unit. We will study it. All those things we will study it. Pipelining means, in a short time, I'll answer you. Pipelining means the instruction is going to be executed one on another immediately. One on another immediately or one by one. That is pipelining. But in 8085, pipelining is not happens means the instructions are not going to be executed one by one. Randomly, they are going to be executed in 8085. So that's what we didn't say it is a pipelining. But 8086, it's a pipelining. Why we have to say pipelining means all the instructions one on another, one by one are going to be executed in a serially. How we have going to be write the instructions. That's what we have to say. It is a pipelining. Pipelining, how it is there? It is connecting one on another, no? One on another. How the supply of water, for example, water supply. There is a pipeline, underground pipelines are there. How they are going to be connected? One piece to another, another piece to another, and finally all make it as a single body, and your water is going to be circulated, right? Up to your home. So like that, it is happening in the 8086, but it will not happening in 8085. That's what 8086 is more popular over than 8085. Am I clear? Whole topic I will explain you later. It comes in this unit number 2. Is it fine?
Yes, sir.
Okay. So this is the one main features of 8086, and minimum and maximum mode also we will clearly explain you later. That topics will come. And in 8086 there are totally 256 interrupts it will support, but the 8085 only supports 5 interrupts. All those interrupts you studied, that is INTR, RST 7.5, RST 6.5, RST 5.5, and trap. Only 5 interrupts are there in the pin diagram, right? In 8085. But here in 8086, it will support 256 interrupts. I'll tell you later on in this chapter again. Just these are the topics. I didn't explain. I'll explain one by one. Next, 8086 will provide memory bank. Memory bank means what? There's a huge memory is available in 8086. It will support a huge memory compared to 8085. And also in the 8086, it will support memory segmentation. What is segmentation? Segmentation means we have to make into a parts of memory. One entire memory is there. We have to make it as a small part of the memory. That one we call it as a segmentation. So in the 8085, it's entirely only one memory is there. There is no segmentation. But in the 8086, the segmentation is occur means small memories are available in a main memory. And 8086 has 16-bit data bus. 8085 is a 8-bit data bus, but here it is a 16-bit data bus. So along with these 6 to 7 points, these 6 to 7 points extra in the 8086. The 8086 will obey whatever all the rules are obeyed by 8085. Out of 8085, these many extra features are there in 8086. That's it to remember. So in this, that pipelining not the 8085, but here it is there, and it will supports minimum and maximum mode, but 8085 will not supports, and 8085 having only a 5 interrupts, but here in 8086 it is a 256 interrupts are there, and 8085 have a small memory, but here a maximum huge memory bank is available, and in the 8086 we have to use a segmentation, small piece of memory within the main memory is available, supports, but it will not there in the 8085. And here it supports 16-bit data bus, but the 8085 is a 8-bit data bus. So these are the main features. Next, I'll move upon architecture. So here one diagram I have to draw by my own. So these notes, clear notes also I will provide you. Don't worry. So in the architecture, we are just studied about entire these blocks of the architecture. So in this, the question may comes, explain the architecture of 8086 in detail. Whenever they have to ask a question, explain the architecture of 8086 in detail, or sometimes they have to ask, explain the different components of 8086. These all are components. Now we will go through it. Sometimes we have to say, see, in this architecture, I have to shaded one line at between. No, see, you observe my cursor. This is the one line I have to make. This is the partition of this architecture. So this architecture mainly divided in two parts. This one upper part at the shaded line as in between. So from above part we have to say it is a bus interface unit. That one we call it as BIU. That is nothing but BIU, bus interface unit, and the next one is EU, nothing but execution unit. So in the architecture of 8086, these two main sections we are going to be studying. What are those? One is execution unit, that is nothing but lower part of this. All this is execution unit, and this upper part, all this one we call it as bus interface unit. So in the bus interface unit, there is a one memory interface, and that is a summation. Summation means what? It is a arithmetic operations. In the arithmetic operations here, 5 segmentations are there: emergency segmentation, code segmentation, stack segmentation, data segmentation, and that is input. So here input pointer. So totally emergency segment, yes. CS is nothing but your code segment. SS is nothing but your stack segment. DS is nothing but your data segments. Okay, so these are the main parts of bus interface unit with the arithmetic and logical units. Along with that, some instruction seem with a 6-byte fetch queue is there. Those are nothing but here. This is the one queue with the 6 instruction. 1, 2, 3, 4, 5, 6. There are totally 6 instructions. All these are nothing but the part of bus interface unit of the architecture of 8086. So in the second part, that is the execution unit. So in this execution, that is the lower part. Here also you have to using some registered, pair registered, that is AH and AL, BH and BL, CH and CL, DH and DL. So previous 8085 registers you are used only BC, DE, H and L, because that is only a 8-bit. But here your 8086 are 16-bit. For that you have to use one more bit extra, that is H. B, C, D. Along with A, B, C, A is used for accumulator in 8085 and B, C, D you are using, right? So here in this, the H alphabet indicates high. H alphabets indicates high and L alphabets indicate low bit. High bit and low bit of 16 bits. Okay, remember, got it point. So in this, you have to use it high bits and low bits. That is with the register of A, B, C, D. And along with that, you are going to use SP, stack pointer, and base pointer, and source index, destination index. SP means stack pointer, BP means base pointer, and SI means source index, DI means destination index. These are the some pointers you are used in the execution point because you are going to hold the address of another instruction that is going to be executed. So, and along with that, you have to using one control system for serial input and output control, timing and control. You are going to be used here to control the system. And next one, here in the execution unit, you are going to be for arithmetic and logical unit. That is nothing but ALU. Here also you have to performing arithmetic unit, and in execution also you have to performing arithmetic unit and logical units. That is going to be given output, and one offer flags you have to use it again. Okay, some students are waiting. Yes, fine, I admit it. So again, some arithmetic and logical units also you have to use it. That is operand flags. There is a operand flags you are used in the flags level. So now each block, what are the block? The bus interface unit, in that these are the 5 blocks, and one is instruction, and in the execution unit, in that registered and pointers indexes, along with that algebraic and logical units operands. So these are the things we are going to be using. Now we will study it one by one. So here in the bus interface unit, see, don't worry, clear notes I'll give you. Don't worry about the notes, just you have to think about, see about these explanations. So in this totally bus interface unit, what the bus interface unit will do, it provides interface of 8086 to other devices. That is, interface is going to be happen with other devices, and it operates with the respect to bus cycles, and this is means for to perform various machine cycle such as memory, read, input and output write, etc. to transfer data with memory and IO devices. And also it performs to generate 20-bit physical address for memory, physical address for memory, that is 20-bit, and also it fetches the instructions from the memory to the output device, and it transfers the data and to from the memory, and also it supports pipelining. This interface is going to be supports pipelining and queue. So in the segmentation, the main component segment is, that is a CS. CS in the sense what? It is a code segment. In it is holds the base segment address for the code segment, and also all the programs are stored in the code segments. So as usual, and it is multiplied by 10h to give a 20-bit physical addresses and to connect with the code segments. So here the next one is a that is uh, DS is the thing that is data segment or data register. That is, we say it is data segment address of the data segment, and it is a multiplied by 10h with the 20 bits physical addresses of data segment, and also the data segment is multiplied 10h, then that becomes a code of that data segment address. And later next I am going to assess, that is nothing but uh, stack segment. In this, it is holds the address of stack, that is holds the address of stack, that is nothing but your stack segment. And yes is nothing but what, that is the extra segment. So this es is nothing but extra segments. That extra means if we need any extra instructions going to connect the device with others, that time we have to use es, that is extra segments. So this is all about your bus interface units. And next one we have to use for address generation circuit. In that bus interface unit, it is a physical address generation circuits. along with generates the 20-bit physical addresses, and using segment and offset address using the formula that is used for the total physical address. The total physical address is nothing but the segment address into 10H, that is offset addresses. So, and also in that 6-byte fetch queue, it is also helps to support a lot. That was entire thing support your bus interface units. So next one, I will come to the execution unit. That's the lower part of this 8086 architecture. 8086 architecture. So in that, it fetches the instruction from the queue in bus interface unit, decodes and execute it. So next, in the whatever that execution is happened from the bus interface unit, that is going to be executed in the execution units. It performs to arithmetic and logical operations, and also it sends a request signals to the bus interface unit to access the external model, and it operates with respect to it operates with respect to all the arithmetic and logicals, whatever the truth table and all the operations plus addition, subtraction, division and multiplications. All those are done by that execution units. So in the execution unit, we have to use some general purpose registers as it is used in our 8086. So here, those general purpose registers are AH, BH, CS, DH along with EL, high, and low, A, B, C, D. Okay, so these general purpose registers are used in the 8086 has for 16-bit general purposes, and that is AX, BX, CX, and DX. Why we have to use X means that is either H or high or low, and also these are available for the programmer for storing values uh, during the programs, and in that arithmetic and logical operations also it is more than helpful for architecture, that is arithmetic and logical unit of your execution units. And also there is some operands. What are the operands? Whatever the two operations is going with a single unit, those are nothing but the operands. That operands we have to done through the flags. Next we will go for that flags also. Okay, so this is all about your architecture. So this entire explanation within today or tomorrow, I will give you. I will make a notes for you. Very easiest notes I will make you. You are easily understanding by studying the notes. As our first unit, how I have to make you easy with my individual notes. Okay. Same way, again, I will provide you notes. Don't worry about that. Just you have to understand the concept of architecture 8086. So next, all of you got clear. Next one, I will move to that instruction sets, that is execution. So next one, some internal operations, some internal and external operations will move to it. So in that internal and external operations, that is nothing but uh, flag registers is also there. Just a second. Here is for registers. Okay. So before that, okay. So this is our internal and operations of 8086. So in the internal operations, allow me in meeting. Anyone is waiting? Anyone is waiting? See why you all become a late comers. I'll check if anyone is waiting. Allow me to meeting. I allowed you. Okay. I'll do one message. Yeah, fine. So it is I got admitted. Okay. So next one is internal operations of 8086 architecture. So in the internal operations, there internally it is operated in three stages. The 8086 is internally operated in three stages. Those are port segment, data segment, and stack segment. So that one we have to categorize it into first fetch, second fetch, third fetch. The first fetch is nothing but that is the first instruction, and the second fetch that is nothing but our second instruction, and the third fetch that is nothing but our third instructions. So by sending one on another the instructions, we have to use totally three operations, internal operations, that is first instruction to second instruction to third instruction to third instruction. Only three operations, that is the instruction queues. So here in the first instruction has an even addresses, and here the first instruction has an odd addresses. So it is for the even addresses and it is for the odd addresses. Okay, some students are again waiting. Yes, fine, admit. Okay, next one. So one more topic that is in the architecture, dear students. Here we are going to study that is flags. So here operands and flags. Okay. So the operands are nothing but here the operand system nothing but these are the 16-bit operands and used for control register to hold the operand temporarily, and also these are available for the program purpose to do the particular task. And in that instruction set registers, we have to use the fetches an operation code, upcode, and from the queue number, so which is the instruction register, and the instruction decoder decodes the particular operand of the operations to information to the control circuit, and this is for your operands. And next one is for the flags. Next one is for the flags. So as I earlier said in the unit number 1, you have to go and study the actual flags in the unit number 2. So now we are going to study that is the flags. So just a second, I will share with you that notes. Just a second. Yes, fine. Here you will got a clear notes. Yes, fine. For dear students, this is the notes I have to prepare for you, and this is the architecture. In that architecture, so now I am going to explain about these flags. That is the architecture flags. So now all the notes, whatever I explained you at the first BIU bus interface in its segmentation like CS register, DS register, CS register, and ES register, and also some instruction pointer. So whatever I explained and all those I have to give any clear notes along with that. Now I'll go to your execution unit. In that execution unit, your flags is comes right. So for the flags, so here flag registers as execution point. There are 9 flags you are going to study it in 8086. In 8085, you studied only 5 flags: zero flag, sign flag, auxiliary carry flag, parity flag, like that. But here you are some more flags are going to be studied. Those are nothing but here I have to clearly mention these flags for 2 types of 6 status conditions. There is a flag signed with 3 control flags. Okay, and also that status flags are attached by the ALU because that is arithmetic and logical units. And also here the control flags are used to control certain operations and changed by the programmers. Okay, so I will share you these notes, clear notes, and see here in that the 0f is the one flag. That one we call it as overflow flag. So totally it is 16 bit. Out of 16 bit, only I have to use this 9 flag. That is the CF carry flag, parity flag, auxiliary carry flag, AF, and zero flag ZF, and sign flag SF, and T flag. T flag is used for trap flag, and IF flag is nothing but your interrupt flag, and DF flag is nothing but your direction flag, and OAP is nothing but your overflow flag. So in this 16-bit data lines, totally 9 flags I have to accumulate it as per your arithmetic and logical units, and remaining 6 I have to make it as a gap, that is with the X mark. Okay, here 4 and this 1, 5, 6, 7. Okay, so totally 16 bits. So in this one by one we'll see now at the first number. So this is the D0, D0 to D615. That is total 16 lines. At this point, there is a carry flag. So this carry flag is 1. The carry flag 1 indicates, because this flag is either high or low, either on or off, either 0 or 1 condition. It will just check the condition, means if it is 0 for some operation and if it is 1 for some other operations. That's what we have to say, these are flags. That's what we have to say, these are the flags. So totally 9 flags are there. That is, 1 is the carry flag. So in the carry flag, if it is 1, then it is carry out for the MSB. Otherwise, there is no any carry. Whenever you are going to do the arithmetic operations, whenever the carry is generated, that time if carry is generated, it indicates 1. If no carry, then it indicates 0. 0 means no carry, and 1 means some carry is there at the most significant bit while doing the arithmetic operations. And also the parity flag. In the parity flag, either it is going to be checked, either the given number is even number or the given number is an odd number. If it is 1, then it indicates that is an even number, and if it is 0, that indicates it is an odd number. And also next I'm going to auxiliary carry flag. So in the auxiliary carry flag, if it is 1, then the carry from lower nibble, the lower nibble to higher nibble, carry is going to be moved. If it is no carry, no auxiliary flag, then it indicates by the 0. 0 indicates it is a no carry, and 1 indicates it is a lower nibble to the higher nibble carry. So these are very important concepts while you are going to do the programming concepts. So next one is the ZF, that is a 0 flag. In the 0 flag, if it is 1, represents the output is 0. If the 0 represents the output is not a 0, because some output you will get it compulsorily. So that is the 0 and 1. 0 means result is 0. 1 means result is 0. 0 means result, something results you have to get it. So next one is the sign flag. How you are going to be sign flag? Either the given number is a positive number or the given number is a negative number. So for that one you are used for sign flag. So in that is the 1 represents MSB is a negative. If 1 in the sense that the most significant bit is a 1, then it indicates the given number is a negative, otherwise the number is positive. That is a sign parity flag. So after that, that is a trinity trap flag. So in the trap flag, either it is checking the condition of single stepping or multiple stepping. So if it is 1 means that is perform single stepping, and if it is 0 means it is no stepping. 1 and single stepping and it is a no stepping, that one is checked by your trap flag. And the another one is interrupt flag. In the interrupt flag, what is the interrupt? Already I said that it is some abnormal conditions while going to be do the execution of the program. So in this interrupt flags, if it is 1, then the interrupt is going to be enabled to solve that abnormalities. If it is no one 0, then it is disabled, because there is no abnormal condition in that execution of the program. So for that, that is make it into disable. So the next one is that is the direction flag, just to show the directions. So either it is going to be auto increment or auto decrement. If the 1 indicates that is auto increment, and if the 0 indicates that is a auto decrement, okay, that is used for string operations, mainly the increment either going to print the string or reverse string. That time you have to use this auto increment and auto decrement. 0 for auto decrement and 1 for auto increment. So next one, the last, that is the overflow flag. Overflow means what? The condition is going to be exceeded. The data flow is going to be exceeded. So here in this, if the this bit is one, then it indicates that overflow is occurred. Overflow is occurred. And if it is a zero, then there is no overflow occurred. So these all nine flags, what are nine flags? That is ca- carry flag, parity flag, auxiliary carry flag, zero flag, sign flag, trap flag, and interrupt flag, and directions flag, and overflow flag. All these explanations I have to mention it here. Just whenever they have to ask the question to you, that is briefly explain about flags used in 8086. That time you are going to be explain all these nine flags in detail, in line by line. You are going to be explain it. So, dear students, today just I have to cover flags and architecture of 8086 in the unit number 2. So I am going to stop here my class. Next one I'll start next of this topic. Just all of you wait for attendance. Just I'm taking attendance. All of you just wait for the attendance. Uh, just just I will make it all of you. Just you have to go through this PPT. Just 1 or 2 minutes. I'll take your attendance. So here, just all of you wait. Uh, okay, dear all students. As earlier I have to started our class today because earlier one madam is busy. So now I will stop it here. Please.
Hello, sir.
Hello, yeah, please.
Sir, please slide scroll down.
Scroll down. Okay, yeah.
No, no, sir. Hello, sir.
You need PPT?
No, sir.
Yeah. Which one you are?
हिंदी हिंदी में बोलूं सर?
हाँ बोलो ना.
हाँ सर, अभी जो आपने दिखाया ना वो पूरा दिखाइए.
Flags.
हाँ, यस सर, फ्लैग्स.
Okay. That flags. One second. Yeah, this one, right?
यस सर.
Is it not clearly visible?
सर और थोड़ा नीचे लीजिए, ऊपर का दिखाइए सर.
क्या बोले?
ऊपर का दिखाइए सर, ऊपर का. ये जरा
ऊपर.
और थोड़ा नीचे लिए. हाँ.
Yeah, this one flag register.
यस सर, यस सर.
Okay, don't do that. I'll share with you these notes. I'll send you these notes. If you need, you have to make some points. Note down these points, no problem.
यस
If you
सर.
note down, you have to note down it. After the completion of this unit, immediately I'll send you these notes. Okay, from my side.
ओके सर.
That's fine. Now, all of you give your attendance. Give your attendance and please, you carry your further work. And even though any doubts, please ask me. Still, you have 10 to 20 minutes. If any doubts, please ask me. Otherwise, you carry your work and after giving attendance.
मन की मरहम